What's CSE mean? There you go. Okay, come on in the chat. What's the reciprocal of sine? Are we just being, or maybe it's being slow today. All right. There we go. Okay, so you guys already know the reciprocal ones. Okay, it's just using them in a different context. You guys know the quotient ones. The quotient ones are sine over cosine equals tangent, cosine over sine equals cotangent. We've been using those already. We're going to learn Pythagoreans today, and then we will probably save the even and odd ones for tomorrow and the next day. Okay, it will probably take us up through Monday to finish this one. All right. And overall, we're just going to, our overarching question is how to use the fundamental trig identities. We are going to basically relearn something that we can do with right triangles. Okay, so what we're going to do today, we can do with right triangles, but we're going to learn it in a different light. Okay, good morning, Leslie. Good morning, Michael. All right, so I'm going to, out in the left-hand column, we're going to use this today to write out our identities, that thing I just texted you in the picture, because I don't seem to have them anywhere else in the notes. And they were supposed, all right, maybe we had them earlier, but then at least we'll have them kind of in this spot. So we're going to recall. Maybe we did, I think maybe we did do them early on, and we just haven't used them in a while. So we know that sine of x equals 1 over cosecant of x. So these are the, actually I should have put a title on that. These are the reciprocal ones. So these are reciprocal. Okay, so reciprocal is sine of x equals 1 over cosecant of x. Cosine of x equals 1 over secant of x. Tangent of x equals 1 over cotangent of x. And then I could go the other direction with these two, right? Cosecant of x is the same as 1 over sine x. Secant of x is the same as 1 over cosine x. And cotangent of x equals 1 over the tangent of x. I'll give you a minute to write those down, okay? All right, let's do the next set of these here. So the next set are called the quotient identities, and you know these ones as well. So quotient, okay. This is where the tangent of x equals the sine of x divided by the cosine of x. And the cotangent of x equals the cosine of x divided by the sine of x. All right, we got those ones down, hopefully. Okay, the last set are called the Pythagoreans, okay? So the Pythagoreans, they're going to be something squared plus something squared equals something squared, right? I'm not spelling Pythagorean right. There we go, Pythagorean. This is where we have sine squared x plus cosine squared x. This squared is going on the trig, equals 1. And then 1 plus tangent squared x equals secant. And you can use an x, you can use a u, you can use, I think the ones in my classroom have u's on them. 1 plus cotangent x equals cosecant squared x. And I can rearrange those in lots of different ways. You'll notice if you look at if you zoom in on the picture and you look at the pink part of the sign, the first column looks like this. The next two columns are those same equations rearranged, okay? So that's where those are. I'm going to give you a minute to write. I'm also resetting the test for somebody here from yesterday in calculus. Let's see, I need second period. Is that the right? Yes, that's the right second period. The one that was originally the 28th. Proctor. I want to do it today. Close. Okay. Okay. No, of course I did not fill out Frontline for my own kid. Either one of them. Okay. Gotta love it. My mom messes up. I came straight into meetings today. All right, here we go. We ready? So let's try this a few times. So what we're going to do is instead of using the right triangles, we are going to use these identities to try to solve for whatever ones they're asking us to do. Okay. So we're going to use the given values to evaluate, if possible, all 6 trig functions. So the very first thing I do is I identify which quadrant I'm in. So I always write all students take calculus. Okay. So I'm just going to use that to help me identify which quadrant I'm in. So I'm going to need your help because I've done a lot of talking and you all haven't yet today. Okay. So I know that my secant is negative. So according to all students take calculus, remember it's quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay. Which 2 quadrants is the secant negative in? Put that in the chat for me. What do you guys think? Which quadrants is secant negative in? Which one is, look at your reciprocal identities. Which one is secant the reciprocal of? Samantha and Javier, can you guys tell me that? What's secant the reciprocal of? You can look up at the yellow sign over here. So what's secant the reciprocal of? Cosine. Okay. So we know that cosine is positive here, right? And positive here. So that means secant's going to be positive in those 2, which mean which quadrants would it have to be negative in? What's left? What was that? Yeah, 2 and 3. All right. So I'm grabbing 2 and 3. All right, and I see a lot of 2 and 3 in my chat. Good job. All right, this here, remember, when it's greater than 0, that means I am positive. So I need to know out of quadrant 2 and quadrant 3, which one is tangent positive in? Can you tell me that in the chat? So which one is tangent positive in? All right, I'm seeing a lot of 3s. Good job. Okay, so I know I'm going right here. Okay, so that's the quadrant. All my answers need to come out for quadrant 3 answers, meaning that tangent and cotangent are positive and everything else is negative. So sine, cosine, cosecant, secant are all negative. So I have to make sure my answers are the right way. Okay. All right. So I always go for the one I get for free. I do my reciprocal first. So tell me in the chat, what's the reciprocal of secant? What can you guys tell me? What's the reciprocal of secant? Yep. Good. Javier, what's the reciprocal of secant? Cosine. Good job. All right, I'm waiting for my chat. My chat's slow. Maybe it's just the internet slow. I came in this morning to like at the last second to get onto a meeting, and it's like everything was like really super slow. It's like, really? Cosine, and we're going to stick with u because that's what they gave us. Cosine of u is going to be the reciprocal of, it's the reciprocal of secant. So I'm just going to flip this over. That's not so bad, and I just got 2 out of the 6 done, right? So now I need to find another thing that has a relationship with a relationship with secant or cosine to be able to calculate my other 6. And again, I'm trying to do this without the triangles. This is another way to do it. So I'm going to come over here and I'm going to pick on my Pythagorean identities. So do you see this one? And it's the pink sign, pink Pythagoreans. So when I say pink sign, I'm talking about the Pythagorean identities. So looking at those Pythagorean identities, I know that sine squared plus cosine squared equals 1. So I'm basically going to use that like a formula, okay? So and I kind of abbreviate. I do this on my paper just so I know, I know it's sine squared plus cosine squared equals 1. And there's a delay even there. Okay, so I know that I have cosine, so I'm going to plug that in for the cosine. I do not have sine, that's what I'm going to solve for. So I'm going to say that I have sine squared of u, because that's the variable they gave me, equals negative 2/3 squared, or plus negative 2/3 squared equals 1. And I'm going to solve that. The piece of trig is going to act like our variable. It's going to act like our x. Ooh, I just reduced everybody here. Okay, so we have sine squared u plus, it's going to be 4/9 equals. Now, I'm going to work smart and I'm not hard, okay? I know that I am going to have to take that 4/9 and subtract it to the other side. So instead of writing 1, what do you think I should write? What would be smarter to write there if I'm going to eventually have to subtract 4/9? What do you think? What would be a fraction that represents 1 that would be in ninths? Put that in my chat here. Okay, we've got 9/9. Perfect. All right, I am going to go ahead and I'm just solving algebra. I'm going to move this to the other side by subtracting it. Hopefully we can do 4 minus 9 in our heads. It's 5/9. Okay. How do I undo this squared? So what's the opposite of squaring? Can you guys tell me that in the chat? What's the opposite of squaring? What do you guys think? What's the opposite of squaring? Isn't it called a square root? Okay, good job. We've got some square roots going on. So we've got to take the square root. Now here's the catch. Typically when we do a square root, don't we normally do a plus minus in front of it? In this case, we know if it's going to be a plus or a minus because we know from over here that in quadrant 3, a sign answer has to be negative. So I know I'm only going to use the negative square root. So it'd be negative square root of 5. And then what's the square root of 9? Tell me in the chat, what's the square root of 9? What's the square root of 9, you guys?
3.
Good. Okay, it is in fact 3. So I've got that one now. So now I've got sine. It took me a little bit longer to get there, but I got it. Again, a different method. We could go back and use the triangles if you're comfortable. You could do that, but I want you to practice it this way today. This is how we use these identities, okay? All right, let's do, what's the reciprocal of sine? What's the reciprocal of sine? Put it in the chat. Reciprocal of sine. What do you guys think? What's the reciprocal of sine? Good. I was quicker this time, you guys. Good job. All right. We've got some cosecant going on. That means I could just flip this to get cosecant. I'm using that reciprocal identity. So cosecant of u equals -3 over square root of 5. Oh, but we've got a radical in the denominator. Now, Webb assign might leave it there. Mrs. Ballard might not. So we're going to practice this. If we leave it, we know we've got the answer. If we have to rationalize it, we would know we would just multiply square root of 5 on the top and the bottom, and then square root of 5 times square root of 5 is just 5. Okay, so depends on the test writer, and we could have any of them pop up. Okay, all right. There's one last thing that we don't have. What 2 trig identities are we missing right now? Put it in the chat. What's missing right now? What do I still not solved for? Is it 1 at all 6? What do you guys think? What's missing? I've got sine, I've got cosine, secant, cosecant. What 2 are missing? Yep. And you guys remember me talking about the SOHCAHTOA sign? It's right up there by the flag. So that's another little place to be able to kind of, when you're in the classroom, look and remember your reciprocals are stacked on top of each other. Okay. All right, we're missing tangent and cotangent. So I could use a lot of different things to get there. Okay. I know that I could use my secant and use a Pythagorean identity, but I want to teach you about a different one. Okay, so I'm going to use a different one. I'm going to pick on and use the quotient identity and show you how to. So I could do that. I could do Pythagorean. I could do quotient. So I'm going to choose quotient identity this time. So I know to get the tangent I of u, I'm going to take my sine value, which we got to be this guy right here, right? So negative square root of 5 over 3. And I'm going to divide that by the cosine value, which we got right here, negative 2 over 3. That's not so bad, right? What happens with those double negatives, everybody? What happens with the double negatives? What do you guys think? Yeah, good. Okay, we definitely know that they become positive. Good. And then check it out with our other favorite new trick, right? Don't these denominators cancel? So don't I just have that it's square root of 5 over 2? So if I can use my quotient identities, wow, that was nice, right? Compared to Pythagorean. Pythagorean are good. But compared to Pythagorean, if I could get away with quotient, I would probably do quotient, okay? All right, and then to get the cotangent, I'm just going to flip the reciprocal. So cotangent of u is going to be 2 over square root of 5. And of course, for the 1,000,000th time, we're going to rationalize. So 2 square root of 5 over 5. I'll give you a minute to catch up, okay? I am not sure we're going to get through 4 today. What time? We get till 10:03. Okay. Let's see what we got here. I think we'll be okay. We might skip. Oh, that one's pretty short. They're actually not too bad. This was the longest one, it looks like. All right. I'm going to keep going. All right, we ready? So here's the good news on this one. Look at this. This last one, they said, hey, you don't have tangent. You just know that tangent's positive. But check this one out. They gave us secant and tangent. You know what that means? 2 reciprocal identities. Woohoo! We like that, right? Reciprocals are the best. All right. So what number is always in the denominator no matter what number I have? Can you guys tell me that? What number is always in the denominator? What do you guys think? Yeah, good. All right, and remember I'm talking any denominator, not isolated to the unit circle denominator, okay? And I'm going to do these ones without the unit circle. I'm just going to use their identities. So I know that there's definitely a 1 down there, okay? Okay, again in the chat, what's the reciprocal of secant? You guys in the room, what's the reciprocal of secant? Good. See, we're getting good at it now that we're having to answer, right? All right, we've got cosine. So I know that the cosine of theta is 1/2. Easy, easy peasy lemon squeezy. Okay. All right, what's the reciprocal of tangent, everybody? What do you guys think? Good. So cotangent is -1 over square root of 3. Now, again, we would probably rationalize that. We'd probably see the rationalized answer on a test. So we've already got 4, and it only took us like 30 seconds to do that, maybe 45, okay? So that's awesome that we already have 4. Okay. Oh, check it out. I just noticed that my other screen is raising its hand. That's nice. That must have been the sound I heard earlier. All right, so I need to figure out how to relate I got to find the 2 that I'm missing. It looks like I am missing sine and cosecant, right? So at least all I have to do is really find sine, and then I'm going to get to cosecant, okay? So I am going to choose, and I get to choose any one of these sets that I want. I'm going to choose to use the Pythagorean identity, okay? Because I know that sine squared plus cosine squared equals 1. So sine squared plus cosine squared equals 1 up in my pink sign, right? So, and all I did is I looked at all my identities that I have, and I found one that related sine and cosine together, okay? I could also find one that relates cotangent and cosecant together if I wanted, because I could have used this one down here, okay? So sine is, we don't know. So we're going to write sine squared, and this time it was in thetas, so thetas. Plus cosine is 1/2. We're going to substitute that in, equals 1. All right, we're going to do 1/2 squared. Oh, I'm writing an equals instead of a plus, would be 1/4 What would be smarter to write instead of 1? What should I write instead of 1 this time? What do you guys think? What do you guys think in the room? What should I write instead of 1? I want to have a denominator of 4. So what's another name for 1? So if I want this denominator to be 4, but it has to reduce to 1, what should I put in the numerator? Yeah, good. Good, good, good. All right, I got lots of 4/4s in my chat. Excellent work. We're going to go ahead and move this over. So sine squared theta equals 3/4 when I subtract. All right, to undo the square, I'm going to square root both sides. Ooh, you know what we didn't figure out? We did not figure out which quadrant we are supposed to be in. So I don't know my plus minus yet. I'm going to do that here in a second. So I've got sine of theta equals, I don't know which one to eliminate yet. So it's either plus or minus square root of 3, or square root of 4 is just 2, which looks like it's on the unit circle, right? It looks like we've got unit circle values. Okay, before I flip, let's take a pause and let's go look at all students take calculus. Okay, I know that my secant is positive. Secant is only positive in quadrant 1 and quadrant 4. So I know I have to be in 1 or 4. Okay. Tangent is a negative value. So help me out in the chat. Am I in quadrant 1 or am I in quadrant 4 if tangent is negative? Put it in the chat. Which one am I in, 1 or 4? Okay, it looks like we are in quadrant 4 right now. So I know that when I take the square root of this, I actually want the negative one. So this is actually going to be negative square root of 3/2. Because we came out with this quadrant. All right, I'm going to flip my reciprocal. Cosecant of theta equals negative 2 over square root of 3. All right. What's the name of the process for me to get rid of that radical in the denominator? What's the name of the process for me to get rid of the radical in the denominator? What do we call that? Put it in the chat for me. All right, I've got a lot of rationalizing going in the chat. So square root of 3 over square root of 3. We've got negative 2 square root of 3/3 for our final answer. So now we have all 6, right? All 6. Give you a minute to make sure you've got it all, and we will see what we can do with, let's see, 4. We still got enough time. We can probably get through the first 4. Last 2 don't look super, super long. Okay, this time I'm going to start with my all students take calculus. I'm going to figure out my quadrants first. That really should have been my first step in that other one. All right, so let's practice this again together. So I know cosecant is negative. Help me out in the chat. Which quadrants is cosecant negative in? Tell me in the chat, which quadrants is cosecant negative? What do you guys think? What's cosecant the reciprocal of? Sine. Okay, so which ones, if S is here, so we know which ones are, so where is sine negative? 1 and 3? I like 3. 1, everything is positive. So so it would be 1 and, or sorry, 3 and 4. Good job, Samantha. Good job. Okay. I see lots of 3s and 4s in the chat. Excellent, excellent, excellent. Okay, so now I need to figure out tangent. Tangent is a positive number. So out of quadrant 3 and quadrant 4, which one of those is tangent positive in? So which quadrant am I going to land in? What do you guys think? What are you guys thinking here in the room? Okay, Javier, where are you at?
1. Well, you said negative, right?
No, we said tangent has to be positive, and I have to choose between 3 and 4. 3. Good job. Good job. Okay, so we've got quadrant 3, everybody, is where we're landing. So all of our answers need to be quadrant 3 answers. Tangent, cotangent positive, sine, cosecant, cosine, and secant all negative. All right, We're going to flip ourselves some reciprocals. We get 2 of those this time. Isn't that nice? All right, so what's the reciprocal of cosecant, everybody? Put it in the chat. What do you guys think here in the room? What's the reciprocal of cosecant? Yeah, sine. Okay, good. Sine of theta equals, remember there's always a 1 in the denominator, so when I flip that, I get -1 over square root of 2. And then we're going to do our favorite thing, rationalizing 1,000,000 times, right? Negative square root of 2 over 2. All right, I got sine, I got cosecant. All right, I am going to go for, what's the reciprocal of tangent, everybody? What's the reciprocal of tangent? What do you guys think? Good. All right, I'm seeing a lot of cotangents in the chat. And then technically that's just 1 over 1. When we flip it, we're just going to get a 1. All right, now I'm going to show you, we could absolutely 100% use our Pythagorean identities. However, I want to show you how to do this with the quotient identity, okay? Because that's another option for us here. And I think you're going to probably like this. So I know that tangent of theta equals the sine of theta over the cosine of theta. I know that tangent is 1, and sine is this mess right here, negative square root of 2 over 2, and we're going to divide that by cosine of theta. Give you a couple seconds to write it. Okay, this here, I'm going to take to the other side. I have to move it by multiplication. Well, good news. Cosine times 1 is just cosine, isn't it? So cosine of theta ends up equaling negative square root of 2 over 2, which it makes sense because in quadrant 3, cosine has to be negative. Okay. All right, I'm only missing, let's see. I am missing, what am I? Oh, I'm just missing secant. What's the reciprocal of secant? Tell me in the chat. What's the reciprocal of secant? We're not listening. What's the reciprocal of secant, you guys? Try again. Look up there. Secant. Cosine. There you go. Okay. It's hard because the letters all flip all over the place, right? So you got to know that there's never 2 C's together. Okay. So there's never 2 C's together. All right. So we know that we've got to flip this. I reversed the way I said the question, didn't I? All right, and then I'm going to rationalize this again, which is kind of silly because we're going to kind of get back to an original answer. So it would be negative square root of 2. Not so bad, right? Not so bad. Okay. We have enough time to do one more, and then you probably will be able. Andy has been falling down on the jokes job this whole week. He'll be here in like 20 minutes, but you guys will be gone already. So he's up on Thursdays. He has to come to school with mom when he's done. All right. This one here is a little bit more right triangle-esque because look, we've got Pythagorean triples there, don't we? This is the last one we're going to do. All right, but we're going to use the same process, okay? I'm going to start with all students take calculus, as always, though. All students take calculus. All right, so I'm noticing sine is negative. That means I have to be in quadrant 3 or 4 because sine is positive in 1 and 2. I'm noticing cotangent is negative. So since cotangent and tangent are positive in quadrant 3, I know that I have to have quadrant 4-like answers. All right, I'm going to flip the reciprocal of sine, which I know is cosecant, so that's going to be negative 13 over 12. I'm going to flip the reciprocal of tangent, cotangent, which I know is tangent, which would be negative 12 over 5. So I've already got 4 out of the 6. This is pretty good, right? I only have to get 2 more. All right, so I am going to choose to do a Pythagorean identity. Okay, so if you're looking at your pink sign or the pink Pythagorean identities, I am going to choose one that relates sine and cosine. So I would go back up to my little list. If I can find my list. And I would take this one that I highlighted in yellow. Sine squared plus cosine squared equals 1. If there's one that comes up, it doesn't come up very often in calculus, but if there's one that comes up, that's the one that comes up every so often. So I know I'm going to do sine squared plus cosine squared equals 1. I know I'm going to substitute in negative 12 over 13 squared plus cosine squared of theta equals 1. All right, I'm going to square that because I really don't know what else to do. So let's see, 12 squared is 144, 13 squared is 169, plus cosine squared theta equals. Just like in all the others, you did like 4 over 4 and 9 over 9. My denominator is 169, so I'm going to do 169 over 169. And then I'm going to subtract that over to the other side. So 169 minus 144 gets us 25 over 169. I'm going to undo that square by taking the square root of both sides. I know that with in the plus minus, cosine in quadrant 4 has to be positive. So cosine of theta would be positive. Let's see, square root of 5 or square root of 25 is 5, and square root of 169 is 13. Yes, Lauren, that says 169 over 169. Were you answering the question that I didn't actually ask because I'm just blasting through this one? It's okay if you are. All right. Last thing we're going to do is we're going to take that secant of theta and we're going to flip it. So we've got 13 over, or we're going to take the cosine and flip it for the secant. We got 13 over 5. All right. Hopefully not too bad today. Okay, that's where we're going to stop. And I think I only gave you like 3 or 4 for homework tonight. So get them done. All right. And I'm sorry it went a little long. We had a little rough time getting started today and our ICANs were a little longer. Remember, we're only going to do another like third of this tomorrow. Hopefully we'll be done a little bit earlier for those of us that are here. Okay. All right. Let's see. Let's see if I can come up with a quick joke for you. Oh, I've got a good one that I can do off the top of my head. You ready? It's not a math joke. Okay. Okay, let me see if I can remember it. What do you call